Okay, so a quick reminder of how this stuff works. Did you notice that this was squared? Did you notice you could factor it then? Because if you can factor it, you should. So, Dominic, can you tell me what that factors to?
X plus 2 and x minus 2.
Excellent. And that leads you to two answers. 2 and negative 2. This one's negative 2 and this one's 2. But be careful, because that's a really common wrong answer, is to just say that. Those are the two answers. No, we don't want it to be 2. Because if we put 2 in, it's going to make it 0 on the bottom, and that's bad, right? So you're supposed to make a number line for these and put on negative 2 and put on 2 and go, it can't be this and it can't be that, but it can be everything else. So remember, these answers are always a number line at the end. Unless the test says that it has to be in interval notation. All right. So I want you to now move to the red one. Iris, can you tell me, these are supposed to be set something, like not equal to 0, but...
Greater than or equal to 0?
Yes, greater or equal to 0. Notice I just take what's under the root. Can that one be factored? No. So then what do? You add 3 to both sides. 2x greater than or equal to 3. X greater or equal to 3/2. That's something you could put on a number line? Sure. I'm going to make it a number line at the end. You didn't have to in this case. Why do you sometimes have to when sometimes you don't? Well, if you just said one thing here, like 2 and negative 2, you aren't listing all the things it could be. This is a way to say all the things it could be, but so is this. That's saying all the things that it could be. So either one of these two would have been okay. All right, and last but not least is this one. It's got two aspects. It's got this part has to be greater or equal to 0. That's an equation. And it's got this part that can't be 0, and that's an equation. And you got to put it all together on one number line. Everybody give it a shot right now. I'll pause for a second while you try to put that all together. It's like the other two, again, except all in one problem. I'll pause while you try that. All right. So this top one, you should have said x minus 3 greater or equal to 0. Add 3x greater or equal to 3. It's a funny looking 3. I'm going to try again. There. This one, x minus 5 not equal 0. Add 5, x not equal 5. I put that all on one number line. Here's 3, here's 5. Here's greater or equal to 3. And then here's not 5. Empty spot right there. It's like you just punched a hole in your graph. And now I put an empty spot at 5. There is my final answer. Who had that one right? A lot of you. Fantastic. All right. So do you get that they're going to get more complicated because you'll have to factor things? Let's make sure you get what I mean. Let's say it's like this. X squared minus 3x minus 4 over x squared minus 100. Do you get that both the top and the bottom can be factored? And so now there's a whole bunch of things that have to go on the number line. And you got to test a whole bunch of intervals. All right, try this one. Act like this is the hardest question on the test. A lot of people got that medium hard question right, so maybe you guys got this. This one's going to involve a lot more testing intervals, though. Alex, can you tell me one of the two and what they factor to?
X minus 4, x plus 1.
That one is x minus 4, x plus 1. Excellent. If people were a little rusty on that, you should have been able to get to the x plus and the x minus pretty quick. Because if this number is negative, it has to be 1 plus and 1 minus. And then the 4 and the 1, well, you just play with it until you figure out that and that add up to negative 3x. Okay. And on the bottom, oh wait, what do I actually do with that though? I get two answers, x equals 4. Do I know if it's bigger than 4 or less than 4? No, I don't. There's a few people that still think that, like, x is bigger than 4 because it has to be greater or equal to 0. No, you don't know which direction to shade. You can't tell from the fact this says greater. So you got to put those numbers on a number line, and then you got to, like, shade to try to figure out where to put them. But we better finish this first. X minus 10, x plus 10. I hope that was easy. It's supposed to be. And so there's two things it can't be. Can't be negative, or 10 for this one, and it can't be negative 10 for this one. So there's 4 numbers on my number line. The smallest of them all is negative 10. And then I got negative 1. And then I've got 4. And then I got 10. Now you can circle them and be careful, because it can't be these two, because remember it's not equal to. So the two 10s, those are going to stay empty circles. I'm going to like hollow them out inside, so there's no chance that I think it's shaded there. And then these two, remember this says or equal to 0? This is okay. In fact, I should shade it in because it can be 4, because it says it can equal 0. And it could be negative 1 because it says or equal to 0. So I'm going to fill those both in. That gets filled in, and that gets filled in. Now, where to shade? How do I decide where to shade? You can test any number. Like if you weren't even sure if 4 was supposed to be shaded or not, you could go put 4 in and just see if it causes a negative under the square root or see if it causes a 0 on the bottom. All we're trying to tell is, does it crash? If I put a 4 in, does it crash? 16 minus 12 is 4. 4 minus 4 is 0. 0 on the top is okay, as long as there's no 0 on the bottom. And I check by putting the 4 in, and no, it doesn't make 0 on the bottom, so 4 was fine. That's why it's shaded in. Okay, so then where do you shade for the rest of it? I don't know. I really honestly don't know. It's not like I, as a math teacher, just psychically know exactly where this thing's going to work. I don't know where it's going to work. So I have to test numbers. Everybody, this is going to take a bit. Test 11, test 5. We'll just use the same numbers as each other. Test 0, which is the best number of all to test. And remember what you're testing for. You're testing to see if the function has a negative under the square root. If it does, then it didn't work. Or testing to see if the bottom was 0. Let's make this negative 2, and let's test negative 11. If I test all of these things, I will then know where to shade. Pain in the butt, but that's how you can know for sure you're right, is you test all those intervals. All right, I'm going to pick random kids. There's 1, 2, 3, 4, 5 numbers to test. Everybody tests all the numbers. And I'm going to call on a couple people and see if they agree whether it works or not. Remember, whether it works means I stick it in, and then I look and see, did this part turn into a negative number? Or did the bottom turn into 0? Now, testing the bottom turning into 0, do you get the only two things that are going to make the bottom 0 are 10 and negative 10? Think about that. Isn't that the only two things in the world that will make the bottom 0? So I really don't have to worry about testing the other things. Everything else will work. I don't have to test those numbers on the bottom. I really just have to test them on the top. You know what I mean? If I'm testing 11, for example, I know 11 is not going to crash the bottom because only 10 crashes the bottom, 10 or negative 10. So 11 really needs to just be tested on the top. I just see if 11 works when I stick it here and here. Does it make my answer turn into a negative square root? So bottom line, everybody, if you tested 11, you should find out that you come out with something big and positive. And are square roots of things that are big and positive okay? Sure. So this worked. Should have shaded that in out there if you're doing it right. How many of you already had that shaded in out there? Okay, awesome. Now I'm just gonna ask people to test and tell me whether 5 worked, whether 0 worked, whether -2 worked, or whether -11 worked. Okay, Kai, pick a number and tell me whether it works or not. -2. All right, we're going to take -2 here, and we're going to see if it works or not. When I put in -2 on the bottom, does it cause a 0 on the bottom? Nope. So that's okay. Tested it out. It was fine. Now I'm going to put in -2 here. I'm going to go square root -2 squared minus 3 parentheses -2 minus 4. So work it out with me. What's this come out to, Kai? And what's that come out to?
6.
So 4 plus 6 is? 10 minus 4? Is it okay to have square root of 6?
No, but
It is.
yeah,
And this is really confusing for a lot of people. It's like, did it work? I don't know. Did it work? As long as it isn't negative. Do you get square roots and negatives would fail? Okay, so we got 6 at the end. And that's okay. It didn't fail. So 6 worked. As long as it didn't come out negative, it was fine. All right, so 6. Or sorry, we were putting in -2. Sorry, we were putting in -2, and it worked. So I'm going to shade this in right here. Has anybody found an area that didn't work? Garrett.
0, because that becomes -4.
He thinks it's 0. I'm going to check him. I'm going to put in a 0 right here and here. And I get 0 minus 0. Oh, square root of -4. You are correct. That area did not work. Doesn't work in there. How many of you can verify that 5 worked? 5 did not fail. Oh, wait. Nobody? Did you try 5? Everybody try 5, and you got to take a stand on this. Does 5 work or not? If I put in a 5 here, 25 minus 100, that's okay. Didn't make a 0 on the bottom. And putting in a 5 here. $25 minus 15. 25 minus 15 is 10. 10 minus 5 is 5. Square root of 5, okay? Yeah, it worked. All right, so I think it works everywhere else. So my final answer is that it can't work. It doesn't work there because it makes the bottom 0. Doesn't work there because it makes the bottom 0. Doesn't work there because it makes the top part negative. And that means it works in all the rest of the spots. That would be harder than anything we'd have on the test, just because it's got so many regions to test. All right. Now, as promised, I want to give you a little quiz. And in this case, I'm going to give you a partner. So do as well as you can. This is going to be a formative experience. This is not summative. Okay? And I'm just going to write the quiz on the board. Saves the pain in the butt of having to have every buddy get a piece of paper and then grade it, and then we waste all the paper. And so we're just going to do it on your iPads. But you do get a partner, and I'll pair you in a moment with the kid I usually pair you with. And it's totally okay to work with them to get these answers. So I'd probably do it on your own and then check with them. And then it's okay to change your answer if you really think they're right. That would not be cheating in this case, okay? All right, so 5 points. Number 1, square root of x minus 7. What's the domain? These are all domain questions, so I don't want to keep saying that. What's the domain of, number 2, 1 over x minus 4. Number 3, square root of x squared minus 3x, let me think here, 6 minus 18. Number 4, it's just an x on the bottom. And number 5, five points. Your answers can be number lines. I'm fine with that for this quiz. I'm gonna pause for a second. Remember, when you're done, totally okay. Now, the one thing I would say is if you check with your neighbor and he says, oh, the answer is actually x has to be greater than 6, you have to show the work for it to get the points. So make sure that you get the work too, you know, like figure out what did they do to get that answer. All right, so here we are, and kids have had a chance to even confer with the kid next to them about the answers. I'm hoping they've got them all. I'd like you to put a score fraction out of 5 right near problem number 1, and hopefully you'll end up with a 5 out of 5, kind of like that, but just put a something out of 5. All right, number 1, you should have set what's underneath the greater or equal to 0, so x is greater than or equal to 7. For this one, you should have set x, the bottom, not equal to 0, so x minus 4 not equal to 0, so x not equal to 4. On a number line that looks like a 4 with an empty spot, and then you shade like this. Do you have to have it as a number line? Yes. If all you wrote was this, you would get it marked wrong. Domain means what can you put in. And if you say x not 4, you're not saying what you can put in. You had to say this. Otherwise, if you said only this, I'll give you half credit. But you have to take off a half a point for not saying all the things that can work, which was from negative infinity to 4 and from 4 to infinity. You can have it on a number line. Okay, number 3. This one needs to be factored and then set greater or equal to 0. So x squared minus 3x minus 18 had to be greater or equal to 0. Then it's x minus 6x plus 3. I think I've got that right. Can anybody verify that? Okay, good. A lot of nodding heads. That's awesome. Then I set a number line with a negative 3 and a 6 on it. And those two spots work. I know that because it's or equals. Then I test around it, and I try a big number like 7. And I see, does it stay greater than 0? That's how you test this kind. So if I put a 7 here and a 7 here, then all of a sudden I have 7 squared is 49 minus 21. That's still a lot. Minus 18 is still positive, and that's all that matters. Is it bigger than 0? Yes, that worked. And if any of you remembered that method I told you the other day, you could draw a parabola like this and go, where is that bigger than 0? Oh, it's bigger than 0 here and here. So there's your final answer. Okay, for number 4, you should have, this is probably the hardest one, honestly. Number 5 is close, but number 4, you should have factored it into x minus 2 and x minus 2 equals, or wait, no, greater or equal to 0. Then you got a whole bunch of testing to do, and you put that on a number line, and you go, here's, oh wait, I guess there's only one number. So 2 is the key number, and it can be 2. And then they want it to be greater than 0. Well, a parabola would look like this. This is kind of weird. Everything works. If you test 3 and you put it in, you'll have a positive number, which is bigger than 0. If you test negative 3, you'll have 2 negatives. A negative times a negative, and that's bigger than 0. So that's weird, but it's a good question because it makes you think. All of that works. But wait, I'm not done. That's the top. That's the top. That's here. I just did that, and basically, it seems like everything works except 2, but even 2 works because it turns into 0, and 0 is okay on the top. What's the one thing it can't be? From down here, x cannot equal 0. So then you got to go find where 0 would be, like there-ish, and punch a hole in your number line. And so there's the final answer, is everything works except 0. Why did I do that? Because again, remember there was an x on the bottom. So can x be allowed to be 0? No. So everything worked except 0. Any questions on that one? I'm definitely seeing a lot of puzzled faces. Kai?
Would you have like 3 different, like when you read it and then
No, because just look at the number line at the end. At the end, do you get the number line is just like filled in everywhere except for one thing?
yeah.
So you don't need to write that in like if you made number lines for it, or sorry, if you made intervals for it, you just have to say from negative infinity to 0, the one thing that doesn't work, and from 0 to infinity. So there's 2 of them, and you always put a union between the 2 answers. And that would be how you do it in interval. Yes?
There's 2 2s, would you just write like would just.
I'm okay with you saying x equals 2 and another x equals 2, but you can't put 2 2s on the number line because there's only one place that's 2. Okay, so yes, there is 2 2s. I get it. That's weird, but there can only be 1 2 on a number line. So, and that 2 works because it says or equal to. And why? Because if you actually stick a 2 in here, the top becomes 0, but that's not illegal. Top of fractions can be 0. All right. So that was a hard one, I know, because it was just strange. Now the last one. If I take x plus 4 and x minus 4, I'm getting smarter about just factoring it right away and saying greater than or equal 0. That's part of it. So let me do that part. Here's negative 4 to 4. Empty spot works here because it's on or equals. Then I'm going to check like 5 and see if it's okay to put in a 5. But wait, I really shouldn't test those intervals yet till I have the stuff on the bottom. On the bottom here, I should factor that. And I hope I set that up right to factor to x minus 3. No, wait a minute. X minus 6 and x plus 1, is that right? Thank you. X minus 6 and x plus 1. So then there's 2 things it can't be. X cannot be 6 and x cannot be negative 1. So here's where 6 is going to go, and it can't be 6. And here's where negative 1 goes, like there-ish, and it can't be negative 1. Now I put empty spots here and here because, again, it's not allowed to be those things. Can't be this, can't be that, period. You can test them if you want, but if you stick it in, you'll find out the bottom 0. Can't have 0 on the bottom of a fraction. Now we have the nasty job of testing all of this, and I'm going to depend on, let's see, who has gotten every problem right so far today? All right. Would you tell me where you think it works and where you think it doesn't work?
So I have it working after 6.
After 6.
Between 4 and 6.
Between 4 and 6, like
And then-
testing 5.
Yeah, and then 4 negative 4. So like negative 4 or lower. Sorry.
Oh, like here? Like that? Okay.
That's what I have.
All right. Now I'm just going to test you by seeing if this really doesn't work. 0 would be right there. 0 would be between negative 1 and 4, and I always like testing 0. So I go back to my original problem, and I put in a 0. And yeah, I get square root of negative 16. That is not allowed, so that for sure doesn't work. That you're right, for sure doesn't work. And if I test like negative 2, that'll make this a negative number because I'm subtracting 16 from it. Can't have square roots of negatives, so you're also right. That doesn't work. I think he's right. Anybody want to dispute that answer? Like you think it's something else? All right. That was a tough one. Honestly, if you can handle that, tomorrow's going to be fine. All right, so there is a review worksheet. Would you please take it out, like open it up, and I'm going to look at it with you and tell you a few that you can skip. And then there's a key for it too. So just open up the worksheet. I want to cut it down a fair amount because we've been practicing a long time and I don't want to give you busy work. Alright, so can you scroll up? Is that it? Is that all the problems? Okay. And let's go to the very top. Like about very bottom of the sheet. Alright. So range. I'm so glad I took this last second. What's that last problem number, please?
13.
Number 13, does it have 3 parts to it?
13, 14, 15.
Oh, it's there's 3 separate problems that are all about range? Okay, cool. All right, we are just going to do the evens on this worksheet. Just evens only. Now, of course, if you want to do the odds, because you kind of like look at your answers and you're, messed that one up, messed that one up. But just do the evens unless you need to do the odds for practice. But one thing we haven't talked about is range. And on range, you have to be able to draw a picture. Would you agree that you know that this is a V-shape shifted right 3? So if I ask you the range of this, don't go like, you never taught us that. Yes, I did. That's a V-shape shifted right 3. Now look at it. Now tell me the range. Isn't that pretty easy once you see the picture? So what is the range? What's the lowest this can go? 0. 2, what's the biggest it can go? Infinity. That's the range of this thing. It's just how low to how high. So remember, for range, you just got to look at the pictures. So we'll only give you parent functions that are easy. We can't give you really complicated things. All right, so that's a really important point. It does touch 0, so bracket on the 0. So that would be the range on that kind of question. That's at the very end of the worksheet if you want to do that one now. It's like the last question. So on range, just make a little sketch and then get range from that. All right, the test is just like that tomorrow. And tomorrow is also strange because I gave an extra morning help day this week. I could have just said, yay, there's no Thursday, so I don't have to do a morning help. I moved it so I'd help anybody who wanted me to help tomorrow morning. Okay, so I'm giving up my Tuesday morning for you. Please feel free to come in. It could be to retake something. It could be to do corrections. It could just be to study for this test because you're a little nervous about it. But I'll be here tomorrow morning. That's all I got for you for today.